So I'll be presenting also some results from the WeaMyL project, and focusing on a live demonstration on how to access and visualize the output from the machine learning platform. So again, my name is Abdulkader Mizgani, and I'm senior scientist at the Norwegian Meteorological Institute. And my apologies if you cannot see me. I have some technical issues with the camera. But anyway, I hope you see my pointer also. So um, here, what you see on the right, it's a very simplified diagram showing the main features of the machine learning platform. There are many other bullets into the whole workflow in the WeaMyL project, but I'm trying to simplify things as much as I can. On top here, you have like the computing part, which is based on a post-processing infrastructure here at MET. It combines both crontab job, which runs a machine learning algorithm written in Python every 5 to 10 minutes. So depending on the availability of the latest radar forecast. It uses mainly data from our THREDDS data server, but I think Arild will talk more about this in his presentation. And so basically the algorithm reads the data from the observations and then perform a new forecast every 5 or maximum 10 minutes using this crontab job, which is an automatic job running the algorithm. And then it saves the data again onto the threads so that it's accessible from outside MET Norway. And in this presentation, I'll focus mainly on how to where to find the data sets and where to find the forecasts, and how to visualize and access those data sets, both in terms of prediction and observation. So in summary, the outline of my presentation today would be how to find the data on threads, both in terms of observations and predictions. And then I will move quickly to an overview how to visualize the data set using this Godiva web portal application. I will leave the opened app access protocol to Arild. Maybe later on he will talk more about this. And then I will finally show how to make fancy visualizations or animations using both observations and forecasts from the machine learning platform using a more advanced Geo Web mapping server. I will be focusing on the radar composite reflectivity that Christopher talked about in the morning session, which is a measure of transmitted power returned to the radar. So it's the radar receives echoes every let's say 3 to 4 minutes, and then it assimilates these echoes and then stores the data in terms of reflectivity from the source of the radar, and it's composite in terms that we compile all the returns from all elevation scans, and these data sets have been corrected also for errors or clutters that we have already seen this morning. I will be also focusing on the 8th of April 2022 from 1640 to 2110. So this event was selected arbitrary just for demonstrating purposes. So all the data that is used in the WeaMyL project, you can find it on our THREDDS data server. And this you can click on this web link here. So it's threads.met.no. And then when you click on it, can you still see my screen?
Yes.
Okay. So you will get a bunch of different data types. So you will find all the WeaMyL related data sets and projects subfolder, and then you need to scroll down to the WeaMyL project. And then you will find some of the satellite data sets and the radar data set that are used for training the model. Some also observation ground-based, but it's not yet ready for now. And you can also find a subfolder which is called model, which includes some results from the machine learning algorithm. We will be using also OpenGeoWeb to get an overview of the data, the content of the data, and then Godiva to get a quick overview of the an example of base reflectivity. And then in the end, as I mentioned, I will give you a quick demo on how to import and export, and then how to connect those different elements in order to create animations. So all the forecasts are stored on our THREDDS data server. If I click here, then I will get to this web window, which specifies you have some technical information, the data size, and some access protocols. As I mentioned, you have this OpenGeoWeb. You can download the file through HTTPS, and we will be using this web mapping server later on. You have this in this viewer section, Godiva, which is browser-based application. I will not, so these are NetCDF files mainly, but I will leave maybe Arul to introduce this in his talk. So by clicking on this Godiva tool, you will open a new window where you will have the title of the data, which is machine learning model output for WeaMyL project. If you click on this plus button, then you can see the content of the different meteorological variables or geographical variables as well. So you have the longitude here, you have the latitude, and you have the equivalent reflectivity factor. So by clicking on the equivalent reflectivity factor, you will pull the data from the file, and then the data will show up on this map here. You can zoom in and out, so this is quite obvious feature. You can also navigate into the map using the mouse, but you can also improve the output of this layer. You can change, for instance, in Norway, we would like to use the North Polar stereographic to visualize the data in a better way. And then you can close this one. So everything is interactive, so you can zoom in and out wherever you want. And here you see on the map you have the equivalent reflectivity factor. So the legend it varies between -50 +50, but it's a smart color palette here. You can also check the time or date. So here it's as I mentioned earlier, it's the 8th of April. Let me know if it's very small so I can zoom in more. This forecast started from 1630, and I stopped recording this 2110. A nice feature with Godiva is that you can also do some animations by selecting 1630, for instance, as a first frame, and then you select. Oops, sorry, and then you select. You select 2110 as the last time frame, and then by clicking on create animation, it will take maybe a bit of time to do the to combine all the data together and then start showing the animation of the base reflectivity factor, how the event is moving. So as you can see here, it's mainly in the northern part of Norway and then part of the of Finland and Sweden, and you have most of the activity on the extreme north here. So you can also use this tool to extract one specific point. If you click, for instance, on one specific maybe location here in central part of Sweden, and then you will be asked to select between different options, and then you can create the time series plot. And then another window will show up showing the temporal evolution of that specific selection of the base reflectivity factor. Another feature here is that you can also change the color palette. If you click on this color legend here, and then you can choose between a bunch of predefined color palettes just to improve maybe some of the visualizations. If you have a huge difference between like small values and high values, then sometimes it's worth it changing the color palette to emphasize more like where you have the highest intensity, the highest values of the base reflectivity, and where you would expect some rainfall, for instance, in this area. And this area, there's probably precipitation happening. So this is one quick way. Once you get access to the THREDDS data server, you can open the file and then you can check the data, and then you can do some animations, like forecaster can do some animations and check the forecasts. I forgot to mention that so when the algorithm generate a new forecast, so it uses the latest observation data set. And the latest observation data set, it's you can find it here in this link, which you have every 5 to 10 minutes. The most recent base reflectivity factor, and by clicking on the file again, you can use the OpenGeoWeb to see the content of the file, or you can use again this Godiva browser based to check the content of the data. Yeah, maybe here there's some technical issues, but anyway, if you open the OpenGeoWeb, then you can see like the content of the data, and maybe something has not been updated into the post-processing infrastructure, and maybe some of the attributes are missing. That's why we cannot visualize the most recent files. But if you go one again to threads.met.no, and then we go directly to the observations, and then we go to remote sensing archive, and then you have this radar reflectivity archive, and then instead of choosing the latest, then we choose maybe previous time. For instance, here you have the 6th, the 3rd of June here, so you can again use this Godiva browser. I think it should show up many weather meteorological variables that one can check, and you can use again this equivalent reflectivity factor to display the data. This takes a longer time because you have an entire day of 5 minutes records. But this is one way of visualizing the content of weather meteorological forecasts that we store here at MET Norway. Okay, let's go back to my presentation. And another way to visualize the results, as I mentioned earlier, is to use a new open Geo Web platform. This is still in development, and it's also using data from our THREDDS MET server. So we have to go back to the presentation and then copy this link here into the this demo GeoWeb. So it's again an interactive tool. I will zoom in so that you can follow me. And then now you can also see like the real forecast. It's live now, so you can see the real forecast over Finland, for instance, here. But you can also import some of the results from the WeaMyL machine learning platform. To do that, so you need to open on this layer manager. I will delete some of the predefined layers, and then we will add an extra layer here that we copied from my presentation. Sorry. And by clicking the plus, there's something wrong here.
You need to use the VMS
yeah.
URL.
Yeah, you're right. Okay, I will copy this VMS link into. I thought I have updated this, but it's still pointing to an old link. Okay. And then by clicking to the plus bottom, you see here there's a new available service, MET Norway THREDDS service. And by clicking on this, you will have, again, the three variables. And by clicking on equivalent reflectivity and you close this window, then you will get a snapshot of the content of the data. You need to do some adjustments here by clicking this auto update on, so it will force the time slider to follow the exact dates of the generated forecasts. Remember that we stored the forecast from 1630 on April 8th to 2110. We can also change again the palette so it looks much nicer. We can also zoom in and out. And we can also like create animations. And but before, you can also like use the mouse to drag or to select a specific time step. You can also use this play button here to start running the animation. So it will show the forecast for this recorded time slice from 1640 to 2110 on the 8th of April 2020. But I have also asked the machine learning algorithm to save those intermediate files. What you have right now, you will always get the latest forecast, but but for those that will be using the machine learning script, they need to add one extra setting to force or to ask the script to save some intermediate files, so you can repeat this exercise. One interesting feature is to comparing the forecast that we had done before to the real observations. And to do so, we need to, and this is very nice feature in this OpenGeoWeb. You can split the window into two different windows, and then we will do the same as what we've done with the forecasts. opening this layer manager and go back to this MET Norway catalog THREDDS data server to pick up the observations. And I think the observations were somewhere maybe here. Yeah, so we need to go back to the 8th of April. And then copy this WMS link into the Geo Web portal. So add a new layer, paste this link, and then press this plus button. So it will take a bit of time to show up, but then again, you have the recorded basic reflectivity factor on the 8th of April. So what you have stored on our THREDDS data server, it's an entire day. So we need to do some additional adjustment to get things look similar to what we have in the left window, which is the forecast. So we need to synchronize those two windows. So both in times of space and both in space and time. And now, for instance, if you zoom in one window, then you will get the exact match in the second window. And we would like to have the same matching time slices. So you need to click on this auto update on bottom here. The observations take a bit of time because the file is much bigger than this one, as it's storing the entire day. If you would like things to look similar, then we need to go back to this layer manager and then choose the same color palette. And then in the end, you will get a similar matching. I hope it will show up soon. Takes some time because maybe my connection is a bit slow. It's weird that we do not get the same color palette, but they should be similar. I might have done something wrong here. Yes. So it's interrupting, I think, because of some connections issues. But what I would like to emphasize is that you can repeat this exercise alone. Everything is open to everyone, and then you can repeat this exercise and try to evaluate or maybe to visualize some of the generated forecasts. I have made a video just in case things are not working well, so I have anticipated this. And here you can, as you can see, as a final product of how to visualize the forecasts along with observations. So this is the same date, which is April 8th from 1640 to 2110. You have to the left, in the left window, you have the forecasts, and in the right, you have the observations. It looks quite similar, despite some slight differences here. For instance, here we have more intense activity in the northern part of Sweden. If you focus on this part here, so we have slightly less intense reflectivity factor here, which would probably lead to less intense rainfall in this area. But globally, I think we are very satisfied with the results and the way how we visualize, the way how a meteorologist or a forecaster can compare the generated results with observations and so on. So this open GeoWeb is still in progress, so additional features may be added into this. And as a future work, I think we will focus on improving and validating the WeaMyL nowcasting model in terms of how the results look like, and trying to forecast more than one time step ahead. And we also would like to do some comparisons between the developed nowcasting models within the WeaMyL project and the actual or the current nowcasting models that are used at MET Norway, in order to be able to see if it adds value, or maybe we're missing something. So this can be a very interesting exercise to do.